Okay, so this is problem 3.5.22. We're trying to find a polynomial function, p of x, with real coefficients having a degree of 6. The leading coefficient is 5, and it has zeros of 6 and 0 and 2 minus 3i, and the 0 that is 0 has a multiplicity of 3. Okay, so first of all, just using the information that we have here, let's start with this. So this 2 minus 3i here has come from a quadratic, and if we know by the conjugate pairs theorem that if 2 minus 3i was a solution, then 2 plus 3i would also be a solution. Okay, so in order to actually see what quadratic this came from, I'm going to actually set these to 0 and then multiply the product. So if I were to subtract 2 and add 3i right here, I would get x minus 2 plus 3i equal to 0, and right here x minus 2 minus 3i equal to 0. Okay, so this product, I'm sort of working backwards here, we would have used the zero product rule to get us here. It wouldn't have looked like this. But if we take x minus 2 plus 3i times the x minus 2 minus 3i, this will actually get us to the quadratic that this came from. Okay, so if I multiply this out, the x times the x is x squared. X times negative 2 is negative 2x. X times the negative 3, negative 3ix. Then I'm going to take the negative 2 through, so negative 2x plus 4 and plus 6i, and then 3ix, and then minus 6i, and minus 9i squared. Okay, so let's go ahead and collect like terms here. So we've got x squared. There's a couple of minus 2x's, so minus 2x and minus 2x is minus 4x. We have the negative 3ix and the positive 3ix, and those add to be 0. Positive 6i and negative 6i add to be 0. Then we've got this plus 4, and then we've got minus 9i squared, and remember that I squared is a negative 1, so that's actually a negative 9 times a negative 1, which is actually a positive 9. Okay, so when we collect like terms there, we actually get x squared minus 4x plus 13. So this 0 right here, the 2 minus 3i and the 2 plus 3i, came from this quadratic. Okay, so then we can just assemble the rest of it. They're telling us that we have a leading coefficient of 5, so we know we've got to have a 5. We have a 0 that is coming from x equals 0, so that would actually just be an x, and they're telling us it's a multiplicity of 3. So that would be the x cubed is giving us the 0 of 0 and a multiplicity of 3. If we have a 0 of 6, that would have come from x minus 6. And then the other zeros are coming from this quadratic right here. Okay, so this is actually the function that they're looking for. They do want you to multiply this out, and so I'll go ahead and do that for you. So first thing is, let's take the we're going to take the 5x cubed and distribute, so we get 5x to the 4th, and then minus 30x to the 3rd. So I just distributed that through the first, through this first factor here, first term. So 5x cubed went through here, and then now we're going to take this and multiply by the quadratic. Okay, so actually I'm going to write it out here because this is going to be long. So this is 5x to the 6th, and so 5x to the 6th, we have minus 20x to the 5th, and then plus 13 times 5 is 65, I think. I'll just check it. So we have 65 x to the 4th. Okay, let's take the minus 30 through. So we got a negative 30 x to the 5th, a positive 120 x to the 4th, and then 30 times the 13, so we get 390, and it's a negative 390 x to the 3rd. Okay, so we just want to collect like terms. We've got an x to the 5th here, negative 20, negative 30, so it's negative 50 x to the 5th. 65 and 120 for the x to the 4th, so 185, and then minus the 390 x to the 3rd. Okay, so that would be your p of x.